Now let us study the force between two long parallel current carrying conductors. Okay. So there are two wires here. Okay. A and B. They are very long and they are infinite also. And then they carry current in same direction here. You can see I1, I2 are in the same direction. Now I have drawn this wires here. Okay, carrying current I1. This current is I2. You can see that around I1 there's a magnetic field. Okay, this magnetic field will go and hit this second wire here. So there's a magnetic field drawn like this way. Okay, in the two dimension way. Now let's see. We use the Fleming right hand thumb rule. Okay, so we keep right hand like this way. You can see the thumb is pointing upwards, and these fingers are pointing into the board here. So magnetic field goes into the board like this way. So if you see from top, it will look like this way. So magnetic field B1 rotates like this way. Okay, you can see that, and we draw the three axes here: x-axis, y-axis, and z-axis. So this is I cap, j cap, and k cap respectively. Okay. Now you can see B1 is going in the direction against I cap, so it will go in the direction of minus I cap. Okay, that's first thing you must know. So let's see what is the magnetic field produced by the first wire. Okay, magnetic field produced by first wire here, that is conductor A. Okay, so let's see this now. We know the formula, that is B is equal to mu naught I divided by 2 pi r. Okay, this we know. So magnetic field produced by first wire is B1. So B1, and mu naught I, which current is going to the first wire, that current is going in the wire, that is I1. Okay, and then you can see this B1 is going against I cap. So you write as minus I cap. Okay, so write the minus in front. So you get here B1 is equal to minus of mu naught I1 divided by 2 pi r, okay, into I cap. So this we know. Let us see next one. What is the magnetic force on B? Okay, what is the force on B now? Okay, so magnetic field is hitting B now, so that will be a force on B. So let's see now. So magnetic force, magnetic force on B. Okay, so that we know the formula we learned, that dF is equal to I dl cross B. So this is a force we know, formula we know. Okay, so dl is a vector, magnetic field is a vector. But now let us see what's the numbers here. Okay, so you can write here the current on the wire, in the wire, that is I2. Okay, and the magnetic force which is hitting, that is B1. Okay, so let's expand this and see. So we get here I2 dl. See, this is going upwards now. Okay, so upwards means it goes in z-axis there, and we'll get k cap also. Okay, that will write separately. B1 sine 90. Okay, so a vector cross b vector, no, and then you also will get here. So we get k cap is there. Okay, because IDL is in this k cap direction. Cross. Okay, so B1 is in which direction here? It is in the I cap direction here. Okay, so I cap. Okay, so we can minus I cap and plus we can take same way. Okay, no problem. So what happens is sine 90. What sine 90 value? That is 0. Okay, so why 0 is they are both perpendicular. Current I1 is coming in like this way, and B1 is going this way. Okay, so both are perpendicular. So sine 90 is 1. Sorry, sine 90 is 1. So here I2 dl B1. Okay, k cap cross j, I cap will come as j cap will come. Okay, so B1, substitute the value of B1 here. So what we get is I2 dl B1, instead of that we get minus sign now. So write the minus in front, minus mu naught I1 divided by 2 pi r into, sorry, j cap here. Okay, j cap is there. Okay, so rearrange and write. So get here minus of mu naught into I1 I2 dl divided by 2 pi r into j cap. So that will be the force there. Okay, so df. So this force is for the small element only. You can see dl. Okay, so what is the force for the full element? Okay, so dl means what? The small length have we taken. If you take the full length, what will be the force? We'll study now. Let me erase that part here. So let us see this now. For the entire length, what happens now? Okay, so let me write down here. That will be the force here. Okay, the net force, that will be equal to minus of mu naught, the same thing only, I1 I2, but you're taking full length now. Full length we write as L. Okay, L into this j cap. See, this is dl and this is L divided by 2 pi r. Okay, so this will be the force for the entire length. Next we will study force by length. Okay, so force per unit length. Force per unit length. That means you must divide force by the length. Okay, so F by L, that will be equal to minus of mu naught I1 I2, divide this by L now, so this L will go away. Okay, divided by 2 pi R into J cap. Okay, so this we must note. Okay, so what is the force per unit length for the first wire? Okay, for the first wire we got this thing. Now let's see the same method we'll see for the second wire also. Okay, let me erase this topics here. Now let us study the magnetic field due to the second conductor. Okay, so this one. Okay, so let's see this now. So this is the second wire here. This will also produce a magnetic field now. So this magnetic field goes and hits the first wire. Okay, so let's see this now. It goes and hits like this way. Okay, you can see this direction here. So these fingers show the magnetic field. This shows the current here. So if you see that it goes like this way. Okay, and the magnetic field comes down here. So this will be the direction of the magnetic field B2. You can see that it's along the I cap direction. Okay, it's very easy to calculate now. Let's see how to do that. So same way only. So magnetic field B is equal to mu naught I divided by 2 pi R. This is the formula we know. Okay, we will see what's magnetic field B2. Okay, so what's current going in B2? Current going in the second wire, that is I2 here. Okay, into this I cap. Okay, we saw B2 is in the same direction as the I cap. Okay, so this is right here. Next, what you must see, what's the magnetic force in A? Okay, so magnetic force on A. So magnetic force on A. So this one goes hits the first one now. So there's a force there. Let's see the force now. So that will be dF is equal to I dl cross B. Okay. So let's see this now. Substitute the values here. So dF vector, and then when it hits A, the current going in A will be I1 and the magnetic field is B2. Okay. So substitute this and right now. So I1 dl B2 sine theta. Okay. So again the angle between this IDL and this magnetic field is 9 degrees, sine 90. Okay. And then also you will see that, okay, we have tried this thing, that is IDL. So this IDL goes up now. Okay. So DL means the small element here. So IDL goes up. So it will be K cap. Okay. So that is K cap. And then cross this one, that is I cap here. Okay. Same like the first equation only. Okay. Let's substitute and see. So what you get is I1 DL sine 90 is 1. Okay. K cap cross I cap is J cap. Okay. So B2 will come here and then J cap here. Okay. So next what you do, substitute value of B2. So what you get is I1 DL, B2 value we know, that is mu naught into I2 divided by 2 pi R into J cap. Okay. So rearrange, right? So it will be mu naught into I1 I2 DL divided by 2 pi R into J cap. Okay. So this is the small force here. Okay. It's for small length. Okay, DL. You take the full wire. Okay. So for the entire wire, let's see what happens now. So the force we take here, that will be equal to mu naught into I1 I2, and instead of DL what you must write? You must write the full length here. So write the full length, that is L divided by 2 pi R into J cap. Okay. Next what you do, same like the first one only. Force per unit length you must study. So force per unit length, that will be this F by L, that's equal to mu naught into I1 I2, and length will cancel now. So divided by 2 pi R will be there into J cap. Okay. So you can see that this one, first one you got minus and this one you got plus. Okay. So what happens? The force are in opposite direction, then they will attract here. Okay. So this is the current here going I1, and this will be the current here, that is I2. So they will be attracting to each other. So the two forces are attractive. Okay. So if the currents go in the same direction, they will attract. Okay. Now let's see what happens if the two forces are in opposite directions. Okay. So two currents are in opposite directions. So this is the current I1 and this is the current here, that is I2. So when they are opposite directions, what happens? They will repel. Okay. So the force will be repulsive force here. So this is about the force between two long parallel current carrying conductors. Thank you for watching.